Hey guys, we are going to be continuing chapter 8 here with section 3. We're going to be talking about rotations. So to graph rotations and to identify rotational symmetry is going to be what you're going to be learning. So here's some vocab. You'll want to pause and copy all of this down. A rotation, sometimes called a spin. A rotation is a transformation that turns a figure about a fixed point called the center of rotation. A figure has rotational symmetry if it can be rotated 180 degrees or less and exactly matches its original figure. So here's how rotations work. Now, first of all, this does not have rotational symmetry. This is just showing you the degrees that it goes. But I want you to notice here that it's going counterclockwise. If you are not told to go clockwise, you always go counterclockwise every single time. So you need to know that that's just the general way that you're going to rotate things, is going kind of to the left, lefty-loosey, counterclockwise. Here we go. Oh, there was a spider. It's a spring now, so I guess all the bugs are coming out. This is how some of you freak out every time you see a bug. Look at that dog. All right, so rotational symmetry. Find the angle of rotation of the figure. When you're going to do this, the first thing that you have to do is figure out how many rotational symmetries there are. And what I'm looking for is if I were to spin this way, how many different ways can I spin it before it's going to look exactly the same? Well, if I spun it one time, I would have, if I kind of count this as my bottom right here, if I spin once, I would have this time would be one rotational symmetry. Right here would be another rotational symmetry. Right there, it would look the same. Right through here it would look the same. And then I'm going to count this one. This is called trivial rotational symmetry, but I still need to count it, which is getting me back to that original figure. So to find the angle of rotation of this, and an angle of rotation is going to be how far do I have to spin it so that it looks like itself again. I take 360, because that's how many degrees are in a full turn, and I divide it by the number of rotational symmetries I found. So this has 5 rotational symmetries, so I'm going to do 360 divided by 5, which equals 72. So this has a rotational symmetry of 72 degrees. Here's one for you to try. The answer will be up in 3, 2, 1. All right, here is what I got. So this one has 5 rotational symmetries where I could spin this to the left and it would look exactly the same. So that's also 72, like our other example. All right, so graphing rotations. Says graph triangle ABC and its image after a rotation of 90 degrees about the origin. Name the coordinates of triangle A prime, B prime, C prime. So let's take a look here. I'm going to change color so you can see it. So I'm rotating about the origin right here, and I'm going to go 90 degrees around this. So one of the things that's going to be really important is as I go from one point to my prime point, or as I go from the pre-image to the image, if this is a rotation of 90 degrees, then this should create 90-degree angles, which means the slope going to that point is going to have an impact. In other words, if this goes up 1 and over 1, then I could go up 1 and over 1 here. And notice, we'll go ahead and just label this B prime, but notice if I were to draw a line that goes from here to here, this creates a 90-degree angle. For C, to do C, I would go, let's see, I go 3 and then 2. So over here I'm going to kind of do the opposite of that, where I'm going to go 2 and then 3. And that's going to be C prime. And notice again, if I draw a line here that goes between the two of these, now this is kind of hard to see because I got multiple lines, but that creates another right angle. A is, that's an easy one because it's up 3 or over 3, up 3. So over here I'm going to do the same thing. And I get A prime. And again, you'll notice if I draw a line to this and then draw a line to this, it creates another 90-degree angle. Here is my triangle. Yours should be better looking than that. I'm trying to do this with the computer. It's a little more difficult. So then it says name the coordinates of vertices A prime, B prime, and C prime. So A prime is, let's see, that is -3, 3. B prime is 1, 1. And C prime is 2, 3. All right, so there are our different vertices. Let's keep going. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, here is what I got. I did not graph the image because I don't have room on my graph here, but this would swing over and it actually kind of look, I'm going to just draw it smaller right here, but your triangle is going to look something like that, going over the x-axis with the B. Actually, it's going to be more like this. There we go. Yeah, so that needs to be what your drawing looks like for that. As long as these are your vertices, then you're fine. So double check the vertices. That's it for today. Very, very short video. Hopefully you took good notes. I will see you all in class.